Imagine having a senior computational designer sitting next to you, ready to build whatever you describe in Grasshopper. That is the promise of Raven. It's an AI-powered plugin that installs directly from Rhino Package Manager, and unlike other tools, Raven is capable of building native Grasshopper scripts from scratch. In this tutorial, I'm going to walk you through everything from the installation process to advanced image-to-script workflows. We're going to see how it handles simple scripts and a bit more complicated ones, and how you can use it to essentially reverse engineer a design just by describing it. Let's take a look. Okay, so let's get started. To open Raven and install Raven, all you need to do is go to the package manager. So I'm going to type package manager here, and you simply need to type Raven. It's going to come up here. Right now mine is already installed, but you can simply click here and then install it, and you'll have the latest version. Once this happens, you need to restart your Rhino, and you should be able to see Raven when you open Grasshopper. You'll see here when I open my Grasshopper window that it's going to have this button on the bottom right corner that says Raven. So all you need to do to start Raven is to click there, and it should open up this chat window similar to ChatGPT window that you usually have. And from here, you can choose to actually log in or sign up. Right now, I'm already signed in with my account, but just to show you, this is their website. And this is where you can actually sign up, and you can also join their subreddit or their Discord, and that's where you'll see the latest iterations, the latest updates. So if you want to sign up, you can simply click here, but keep in mind that there is, of course, a free version that you can use, but you have limited usage and you have daily and weekly resets. And of course, you have the Pro version, which is around $50 a month. And you also have a yearly option as well. So once you create your account, we can go back to Rhino and let's start. So I'm going to simply click on the Raven button. Okay, so once you open Raven, you'll notice that there is this button here that you can click on. And this actually shows you all of the plugins that you have inside of your installation in Grasshopper. So Raven will automatically recognize these plugins, which means that if you want to use some of the components from those plugins, you can simply click and it will populate this context. So the more plugins you have, the more context you'll fill out. So you need to be careful not to fill out too much context, because that can slow down the results. So let's start with something simple. So I'm going to simply just see, okay, can I learn Grasshopper with this? So I'm going to ask it something with voice, and you will see that the text will transcribe automatically here. I'm trying to learn Grasshopper. Can you please explain to me how to deal with divide curve component? It would be really helpful if you can give me one or two examples where this component is used and explain what it's used for. Okay, and you can see that this text got copied, and now I'm going to click on send, and let's wait to see the results. Right now it says that it's thinking, so it's evaluating what I gave it. Essentially, we're giving it a prompt, and you usually want to have very clear messaging when you're sending these prompts, because the clearer your message is, the better the response would be. So we can see that it created already some outputs here. It's telling me here are the main inputs and outputs. So C for curve, N for count, and then K for kinks. And then it's now explaining what it's doing here. It's explaining what the outputs are: points, tangents, parametric. Let's start with a simple example. I'll create a curve and divide it into number of points that you can control with a slider. Okay, it seems that it created some planes here. So let's just double check this. There we go. So there's the small script. So we have the curve. We have the point on the curve, 2 points. Then we have divide curve component here. And then we have perpendicular planes with circles on the curves. Okay, and then we have the circular radius. So maybe I can say something, and this is where I control the number of divisions, so you can see. So maybe I can say something like this. Can you please replace the circles with spheres and make sure that I can control the size of those spheres, and this size should be random, and I want a slider that will control the randomness of these spheres. On top of that, I would like to have a curve that is a little bit more curvy. This one is too simple, so maybe you can create some sort of NURBS curve for me for this example. So now let's send this over. And essentially, I'm speaking with it and I'm telling it what I want to do and what I want to change. Now let's wait for it to see what the result would be. Okay, so it started doing its thing. It's completely change the script, you can see we have multiple points. It created a random component. There it is. Created the spheres. And now I can control with the number of slider. I can control the divisions. And here I can control the randomness of the size of the spheres. Okay, so that's quite interesting. And you can see here the result. And you can see this is like a space curve. It's in 3D. And again, here we're controlling the divisions. Here we're controlling the randomness. Quite cool. Okay. Now let's do something a little bit more complex. I will try to create some sort of a grid for a facade, and I'll try to create some sort of paneling for this. Okay, so now let's describe our next task. I'm gonna start recording now. Thank you for this. Now I wanna create something completely different. You can delete everything that you created here so far. And our plan is to create some sort of a design for a facade that is going to be something like orthogonal grid that will have panels. And I want to be able to control this orthogonal grid, and also want to be able to control the actual design of the panels. To start with, let's start with something simple. Please create this grid, and then I'm going to give you further instructions. The overall size of the grid should be something like 20 by 10 meters, and make sure that the panels are around 1 meter in X and Y direction. Okay, so let's see if that's gonna work. Now it should create those panels. And this is funny because I don't know yet what this is gonna be. So we're testing it as we're using it. And we're seeing how this algorithm that Raven has is gonna handle the design. So it started and it deleted everything that we had from before, which is correct. Now it's going to create 20 by 10 grid, created the facade grid. Okay. Let me know what you would like to do with the panels next. Okay. So now I want to be able to create surfaces from those facade panels. So they need to be rectangular panels. And I want to be able to control their thickness. And I want to have 1 point or 2 points that are going to be attractor points that I can manipulate and move. And by moving them, the height of these panels or the thickness of these panels is going to be changed. So the closer I am to the point, the smaller the thickness of the panel should be. And the furthest away I'm from the point, the tallest or more thick the panel should be. Let's work on this now. Okay, so this is just like a simple Attractor script. It's nothing too complex yet. We're just testing out this to see if we can create some designs. And let's see how this will turn out. So right now it has the grid. There we go. It populated the grid with secondary surfaces. So it has boundary surface. It has the panel centers. Well, let's see. Okay, so now it created, there's the point. This is the result based on the single point. So it has 1 point, and I can actually move this, and you will see that the panels will move as I move the point. And this is just like that, you created something parametric. Okay. This is great, but I actually wanted to have 2 attractor points. Can you make 1 more for me? Okay. So now we're getting a little bit more complex, meaning now we're going to have 2 attractor points that we can manipulate and play with. Okay, there we go. It gave me the second point, and now it's doing the remapping. I can see it here. You have 2 attractor points. Let me just see. So it's actually a little bit too dense here. There's 1 point, there's the second point. So if I move this, this is what's going to happen. Okay. I can see the result. If I go closer here, there we go. So this all makes sense, but maybe I want to modify here. I want to, let's say, fix a little bit of script. So what I can do here, I can just give it a screenshot like this, and I can say, all right, this is good for now. Can you please clean up the script a little bit and possibly create some groups, because right now it's not really readable. Okay, so even though the script is perfectly readable, I just wanted to show you one feature of Raven that is going to kind of clean up your script a little bit. And you'll see this in a minute, because it has this automatic way of creating groups in Grasshopper canvas and organizing them based on what makes sense. So in this case, it has panel, there we go. So still working on it. So it has, let me see, Attractor, Attractor points, panel extrusion, and facade grid. Okay, so it kind of created these three big groups, which makes sense. It allows us to see a little bit better what we can control. I'm not a big fan of these thick, these big colors, but we can always modify that. Now I want to try with the curve. So I'm going to say something like, okay, this worked perfectly. Thank you for this. Can you now, instead of 2 points, can we make a NURBS curve that is going to be influencing the actual attractor algorithm? Okay, so let's see if it's going to create NURBS curve. And this is going to allow us to pretty much play with the curve in Rhino. And it's going to modify the actual design right here. Okay, so here we have a first problem. It says that it created it, but the curve is actually missing. So let me see what happened here. Distance to curve. Okay, so simply we don't have the curve inside. Let me just double check. If I simply create a curve here, this should be able to solve the problem. Let me see. Set one curve, and there we go. So now we have the curve, and we can of course, modify the curve and play with the script just like that. So just so you know that this, works perfectly, we can of course go all the way until the end, and we can bake this, put it on a new layer, and you see this in Rhino without any kind of problems. So that's how easy it is to create your own parametric script, and that's how you can play with Raven. Okay, now we're going to do one experiment. I want to actually attach the image that we have here in the folder. So this was the tutorial that I did a lot of years ago with Grasshopper. So I just wanted to see if now Raven can actually recreate this. And I'm going to plug those images here. Let me just see if drag and drop will work. Okay, it will not work. So I need to definitely use copy paste. So I'm going to simply take the screenshot and I'm going to paste it here. And then I'm going to also do the same thing for the other image. I'm going to take a screenshot and I'm going to paste it here. So now first I'm going to say something like this. Can you please describe what you see on these images? I'm planning on creating a script in Grasshopper that will create this parametric wall. So I'm just curious to see how you'll do it. Okay, so let's see what it's going to say. Hopefully we're going to have some progress with this. I haven't tested this before, so we'll see. Usually first it's going to give me the response, then I'll need to approve the plan if it wants to start building. So let's take a look. Okay, so it has the answer. The images show parametric wall composed of numerous thin vertical fins. The overall shape of wall is gentle, undulating wave. The fins are not in straight line, but offset from central path. Okay, I can certainly help you create Grasshopper script for this. Here's my plan. Establish a baseline, define fin positions, create a wave, introduce rotation, build the fins. Okay, so maybe I can actually just guide it a little bit to tell it how it can be done. So I'm going to actually describe how I want it to build it, and then let's see if it's going to do it. Okay, so this is my proposal to build this. I'm planning on building this with NURBS curves. So I want you to create 3 NURBS curves, one at the top, one at the bottom, and one at the middle. The creation of NURBS curves can be actually created by having multiple points in one single line, and those points can be offset randomly on both directions. And by offsetting these points, we're going to get different types of curves. And by controlling the random slider, we're going to be able to randomly control this curve, and this NURBS curve is going to be created based on those points. So we need to repeat that step 2 times for the top and for the middle, and then we're going to do a loft of all of these curves to create a surface. And then we're going to use, for example, isotrim component to divide this surface vertically, and we're going to use call index to subtract every second panel, and then we're gonna extrude it in the normal direction. Can we make this happen? Okay, so now I gave it this prompt, and let's see if it can make it happen. So essentially what we did this tutorial a while back, we had first one big line, and then we divided this line in multiple segments. In each segment we had like the random position of the points like this. The points could be on any position here. And then we create a NURBS curve based on the position of those points. And we do the same thing on the top. And this random slider can control the sliding of the points. And then that kind of gives us the overall, surface. And then we divide the surface in multiple parts and just extrude it. So it's not super complex, but let's see how it handles it. Okay, this is a clever and robust way to approach it. I can definitely build that for you. Let's start by creating conditional elements, control sliders for the wall's dimensions, and a series of points that will define the bottom curve. I'll add sliders for the overall length of the wall, the number of points to define the curves, the height of the middle and top curves. Then I will create a first set of points along a straight line at the base. Okay, yes, please proceed. So now I give it a green light. And now we should be able to start seeing the script come to life. Let's take a look. Okay, so it finished the first step and I can see that, it created the script, but there is a couple of things that I noticed that need to be fixed. You can see that it divided it horizontally instead of vertically. And also some of these curves are quite mingled. So we need to fix that. Thinking that maybe the density needs to be a little bit less. Let me just double check number of fins. So let's do here maybe 50, just to see if this is gonna make a difference. Okay, yes, but we need to also modify the curve. So it's using interpolate curve, but it's better to use NURBS curve. So I'm gonna ask it if it can use NURBS curve. Can you please use NURBS curve component instead of interpolate curve component? Okay, so I just said, okay, please replace interpolate with NURBS curve because I think that will give us better result. Okay, and here it is. It actually replaced the NURBS curves components, which is good. So now the wall looks a little bit better. We need to flip it, of course. So I'm gonna give it a screenshot like this, and I'll say the following. The current division of the panels is horizontal, and I wanted this to be vertical division. Can you please make it vertical? Okay, and after some time, here it is. It managed to fix the problem. It actually divided it in multiple parts here. So you can see that we have that similar look like we have here in this tutorial we did a while back. So now just to verify everything is working, I'm gonna bake this and let's put it on one layer and let's check it out in the Rhino viewport. So there it is. Let me just see if we can maybe modify the color so it's a little bit more visible. And that's the wall. I'm quite happy with how it turned out. So hopefully now you have a better idea of what you can do with Raven, how you can play with it. So what I showed you here today is just scratching the surface. If you want to truly master this tool and see how it handles complex, heavy workflows with other plugins like Ladybug or Lunchbox, I would invite you to join our next workshop in December. We're bringing in the actual creator of Raven, Moritz Ritual, to teach us live. It's going to be a fully hands-on session where we push this tool to its limits, and it's happening exclusively inside of How to Rhino Premium group. If this seems interesting to you, click the first link in the description to join the group, and I'll see you inside the workshop.